Inverse trig functions. Little review. Sine of theta was equal to what variable? X or Y? Dalton can tell us why.
Oh, why?
Why? Because? Why would you sin? Very good. Okay, that's one way you could remember it. Therefore, cosine of theta was equal to which variable? X. And tangent of theta then is equal to?
Y over X.
Very good. Y over X. So there's kind of your foundation for today. You know, the thing is theta is just a variable, and it's a goofy looking variable that indicates an angle measure. And the thing is, you know, if I have the sine of theta is equal to 3 over 5, that's all fine and dandy. But how would I solve for theta? How would I get theta by itself? Yeah, we would love to say divide both sides by sine, because the inverse of multiplication is what? Division. Let's do this. The inverse of addition is what? Yep. We've gotten to the point now where that we can say the inverse of an exponent is what? The square root. Very good. Whatever that root may be. But again, the question is, well, what's the inverse of a trig function? Well, there is really none. Therefore, they actually call it the inverse trig function. Okay? We got to be able to undo it somehow. So that's why they call it the inverse trig functions. It's the addition to subtraction. It's the multiplication to division. It's the root of the power. Therefore, if we have sine of theta is equal to some value of a, and we want to solve for theta, then we can say theta is going to be equal to the inverse sine of that a value. It is not -1, that is the inverse sine. It's what allows us to undo it. Same idea goes for cosine as well as sine, or tangent. We have a value for a, so don't see a as a variable, but instead view theta as a variable that we want to solve for. We just want to solve for theta today. Unit circles, if you don't have those out, why don't we go ahead and find those? We start off with example number 1, where it asks us to describe all the values of the inverse sine of square root of 3 over 2. So again, sine is which variable, x or y? Y. So let's go to our unit circle and let's find where the y value is this square root of 3 over 2. Can you identify where it's at? If you find it, go ahead and say it. How many degrees? 270?
Wait, you said, never mind. 60. 60, yeah.
Yeah, positive square root of 3 over 2, so we have it up here at 60. And anywhere else? Yeah, it's also located at 120, right? So you can almost think of it like Wheel of Fortune. As long as we land at 60 degrees or 120 degrees, we're winners. Okay? That will get us that y value to be the square root of 3 over 2. Because again, it's sine. Okay? So what do we need to write for our answer? We start by identifying, we always like to use pi if we can. So 60 degrees, let's go back and look at the pi value there. or the radian value. That is pi over 3. Radian value here is 2 pi over 3. Okay, so pi over 3 and 2 pi over 3. The thing is, if we're on the Wheel of Fortune, how many times are on, Wheel of Fortune, how many times does that wheel go around? A lot, okay? And for the unit circle, you can go around as many times as you want to. So if it says to describe all the values, what we need to do is indicate, well, go around once, 2 times, 3 times, 4 times, and etc. The good news is how many radians are in a full circle? Good question. Let me ask you this. How many degrees are in a full circle? 360. We got that one memorized. Therefore, how many radians? Got to include pi.
2 pi.
Yeah, 2 pi. Very good. Okay. So therefore, the other way you can look at it is I found the nail in the tire. As long as I spin this tire full 2 pi radians, I'll get back to the nail, right?
Yes.
And if I spin it a full rotation again, I'm back there. In a full rotation, I'm back to it again. Okay? So what I could do is once I establish I'm at pi over 3, what I can do is add 2 pi to it, and I can spin that a full rotation any n number of times. And it'll get me back to the same location. I'm getting very technical with it. I'm not overly concerned with this 2 pi times n idea. I'm more concerned with getting pi over 3. If you give me pi over 3 and 2 pi over 3, it'll be 4 points out of 5. But again, there's another nail located in the tire. It's at 2 pi over 3. But again, as long as I find that nail, as long as I make one full rotation, I'm going to be back to it. So again, 2 pi n. I could go 4 pi, I could go 6 pi, I could go 8 pi, you name it. Everybody okay with that idea? So this idea of having to go around the unit circle multiple times is kind of annoying, right? And if you were to plug this into your calculator isn't going to give you infinitely many answers. It's only going to give you one. So that's why we introduced this idea of restricting the domain for these trig functions. Let's start with sine. First of all, if we use the capital letter for sine, that's indicating that we are going to restrict the domain, so capital S here. If we say we're looking for the restricted value for sine, that means when we look at the unit circle, we are no longer worried about the values that could appear on the left side of this circle, but instead on the right side. Cosine of theta. Again, multiple answers is annoying, and your calculator is only going to give you one. Therefore, instead of the right, now for cosine, it's going to give you any answer that's going to appear on the top half of the unit circle, between 0 and pi. Or between 0 and 180 degrees. Here it was between, for sine, let's go back to it, pi over 2 and 3 pi over 2. And lastly, for tangent, this once again goes back to looking to the right-hand side, which again is pi over 2, 3 pi over 2. So before we move on, let's maybe go back and take a look at example number 1 again. Let's take our calculators out. If you have found sine, cosine, and tangent, you have actually found the inverse sine and inverse cosine and inverse tangent. All you have to use is the second button. Notice if you look here, sine, cosine, tangent, they got the inverse right above it, shift key. Let's go ahead and do that real quick. And just so we get the exact amount, let's make sure our calculators are in degree mode. I know I'm going back and forth, but put it in degree mode first. And we said that square root of 3 over 2, let's plug it in. So do inverse sine square root of 3 over 2, end parentheses, hit the enter button. What do you get? 60. Very good. That was one of our solutions, right? Right there. Good, right? But again, notice it. Kylie, did you get it?
No, I just give him domain error.
Domain error. Inverse sine square root 3 divided by 2. Plug it in like that. Make sure if you put the square root, it'll give you that parentheses. So when you plug it into your calculator, inverse sine, and then you do the square root, it gives you the parentheses. Make sure you close that off, then divide by 2, and then close this parenthesis there. But again, should come up with 60, right? Okay. Notice, again, we had 2 answers to begin with. But again, your calculator is programmed to give you the answer that falls within the restricted area. Notice we did sine, so it's only going to give you the answer that occurs here on the right half of the unit circle. Therefore, just the 60. It ignored the 120. Make sense? If you were to do cosine, again, you would find 2 answers. You'd probably find one here and here, or here and here. But your calculator is going to only give you the one that occurs up in the top half. Make sense? It's a nice way of eliminating all of those possible solutions that you could come up with. Okay? So while a restricted domain may seem confusing, it's actually very, very nice for us because we can focus just on that one answer as opposed to infinitely many. Example number 3 is really just doing some algebra skills, but now we need to work on solving for theta. And using the idea of the inverse trig function being the inverse of the trig function. 2 times the cosine of theta is equal to the square root of 3, and they want us to give our answers for any degree between 0 and 360. So first thing, again, we're solving for theta. First thing we want to do is divide by 2. I will tell you, when you solve for these trig functions, you will always do the inverse trig function last. So before your very last step, this is what you should see. You should see the trig function of theta equal some value over there on the right. And again, how do we solve for theta? We use the inverse. Very good. Now again, we could give our answer in degree mode or in radian mode. But which one do we want to use here? Actually, we want to use degrees. And I know that because it says between 0 and 360 degrees. So that's how you know which one to get, right? Because again, theta is an angle measure. And we have 2 angle measures. We have degrees and we have radians. So anytime, I will tell you, anytime you solve for theta, it'll always be an angle measure, whether it's degrees or radians. Let's go ahead and plug this in. Cosine. Actually, we don't want to plug this in. Let's go to our unit circle. Cosine is which variable, x or y? X. Let's see where we can find where that x value is the square root of 3 over 2.
330.
Yep. First one we found was 30 degrees. And where else does the square root of 3 over 2 occur? Well, it occurs at 330. Do both of these answers fall within this interval? Yes, they do. So I have to give both of them. If they would have said between 0 and 180 degrees, I would only put 30. Let's try another one. 5 times the sine of theta is equal to 5. for 0 to 360. Step number 1, what do we do? Yep, divide by 5. So I have the sine of theta is equal to 1. What's the inverse of a trig function? The inverse trig function, yeah. An appropriate name, right? If you understand what it's used for. Yeah. Just like addition is the inverse of subtraction. Sine is x or y? Y. So we go to our unit circle. We look for where the y value is 1. And where's that located at? 90 degrees. Very good. Anywhere else? No. You could go right below it, but then it would be -1. Don't want that. So for that one, you only have one answer. Let's try another one. 6 times the sine of theta plus 3 equals 0. And now it's telling us for any theta, or where theta is any real number of radians. Step number 1, what do we do? Subtract 3. Yes. Then divide. I have the sine of theta is equal to -1/2. Solve for theta. Inverse trig function. Any real number of radians, so now we want the radian angle measure. Sine is y. We look where the y value is -1/2. Do we see it? Yeah. What are they?
Uh, 2, 10, and 15.
But which one do we want? Degrees or radians? Radians. So you're right with the 210, but instead we need to write it with the radian measure, which is 7 pi over 6. 330, you're right, but 11 pi over 6. Now it says for any real number of radians, so how many times can we go around now? Infinitely many, okay? The wheel goes on forever. So now it goes back to this idea. The idea that we started with. As long as I go any multiple of 2 pi, I'll get back to the nail on the tire. Or back to $1 million on the Wheel of Fortune. Last one. A pair of hikers plan to walk from a camping ground to a waterfall. The waterfall is 2.5 miles east, half mile north, to the nearest degree. In what direction should the hikers head? So we pick a point. Tells us we're going to walk 2.5 miles east. And then we're going to go a half a mile north. We want to know at what angle theta should I walk at to get to my point. And this is where inverse trig functions are mainly used. This is where we really like to use them. We're looking for this angle right here. Therefore, we're given two sides of a right triangle. We want to use our trig functions. So SOHCAHTOA. Let's identify the 2.5 would be what to this angle? Opposite, adjacent, or hypotenuse? Be your adjacent. What's the 0.5? Opposite. So again, if I look at SOHCAHTOA, The trig functions are just tools that I can use, but I don't have to use all of them. All I need to use is one of them. Which one do we use here? Why?
Two opposite and adjacent.
Because tangent has both the opposite as well as the adjacent legs. And that's what we're dealing with here. So good. We are looking at tangent of the angle measure is going to be equal to the opposite side, which is 0.5, divided by the adjacent, which is 2.5. And again, how do we solve for theta? Inverse trig functions. So, theta is going to be equal to the inverse tangent of 0.5 over 2.5. Don't worry about the decimals, the calculator can handle it. Probably want to give degrees because if we tell this to our buddy, they probably don't know a whole lot about radians. If they wanted the radian measure, well, let's take a look at it. To the nearest degree. There we go. So make sure your calculator is set in degree mode. And they said to the nearest degree. So the nearest whole number degree would be what? What are you guys finding? 11? So you would tell your buddy you need to walk at an 11-degree angle. Pretty steep. Which makes sense. Going much further horizontally than we are vertically. A, D, and H. Last three.